We are now recording. So, welcome to Java. Everybody happy to be here this early in the morning?
Yep.
Yes.
Love it. A go-getter crowd. Awesome. You're gonna need it. So, Java. This is the one. This is the big one. A lot of people, if you've heard about this course, coming into this course from last semester, from people who may have or may not have been successful in previous attempts at this course, probably people say that this is a hard course. And I would say that that reputation is entirely deserved. There's a question at the back? No? Okay. So, my understanding, and this is a relatively stable statistic, is that this course has typically in this semester about a 50% failure rate. And that's you know, when I was in university, it was long enough ago that they did that thing in first year where it said, look to your left, look to your right, one of you is going to graduate, right? In this course, you only have to look in one direction, and one of you is going to graduate. Statistically speaking, it's very important to put a disclaimer in about statistics, all right? Statistics are a broad-based phenomenon. They do not predict the behavior of any specific individual in the class. Just because this class has typically a very high failure rate does not mean that you, the person sitting in this room, cannot succeed, right? But it will take hard work, it'll take guts, it'll take coming to class, and it will take paying attention to teachers. Java is a real programming language. There comes a time in every person's life when they must put away childish things, and in this case that's Python. We will be studying a real programming language that has a fair amount of complexity to it. A lot of what this course is going to focus on is object-oriented programming. The first couple of weeks will mostly be getting your feet under you in Java. We're going to be sort of going back over a lot of the material that we already, come on in, a lot of the material that you covered in fundamentals, or at least you were supposed to cover in fundamentals. My understanding is that depending on what prof you get for fundamentals, sometimes more or less is effectively covered. So, first 2 weeks, we're going to be covering how do I print things, what does an if statement look like in Java, what does a loop look like in Java, all of these fundamentals topics that hopefully you got a solid grasp on last semester. But do not get complacent, for very quickly we will be moving on to much more advanced topics. Does anybody have any idea what object-oriented programming is? You at the back, sir.
It is class-based, and it's creating objects that, through classes, that can be manipulated. Instead of using functions that just manipulate data, you can create an object as an object to manipulate.
Yes. So what the whole point of object-oriented programming is, we are changing the fundamental layer of abstraction, right? In purely imperative languages, and the way that you folks used Python last semester makes it kind of indistinguishable from a language that doesn't even have object-oriented constructs. Python does have object-oriented. In my opinion, it is correct not to study object-oriented in Python. Because for various reasons, you'll find over very quickly that I'm not a huge fan of snake language. But basically...
It's already pretty apparent. It's already pretty apparent.
Good. Then we're coming to understand each other. So, in Java, basically, you're working in a strong, statically typed system, which means you will see more compiler errors, which, you know those articles where it's like, you know, volcano destroys village, but actually it's a good thing? That's kind of the attitude that you should have towards compiler errors. Every compiler error that you get is useful and helpful and correct, and you are the one that's wrong. The compiler is always correct, right? So when the compiler gives you less information, that in the end is less helpful, even though it sort of helps you kind of slide your poorly written kludgy code through a little bit more easily in dynamic languages, such as Python. So Java is a more strict language. You are required to write your code more rigorously, and as a consequence, your code ends up better formulated and more correct, sort of in a general sense. But there is a period of adjustment, shall we say, and you need to learn to love. You need to learn to love your compiler in the same way that you know, Stockholm Syndrome patient learns to love their captor. So, what was I even talking about? Object-oriented programming, that's right. So, the way that you used Python last semester makes it fundamentally no different from C. I assume that most people in the room have heard of the C programming language. Hands up if you haven't. Good. Oh, okay. So C is a very, very important language historically, which was developed in the late 60s, early 70s, which was so influential and popular because it solved the portability problem that existed at the time. It became so popular, basically every language is C-based that you use, right? Python is C-based. In fact, Python's interpreter is written in C. There are languages that the compiler or interpreter is written in the language that it's compiling, and there are languages where that's not the case. Python did not implement its own interpreter in Python. C's compiler is written in C, so there you go. But the C language forms the kind of basis for, you know, Java, C#, C++, obviously, Objective-C, Python, PHP, JavaScript, all of these languages in some way are derived from C. But C is not an object-oriented language. It does not contain classes. It does not contain objects. All it has are functions and structures. Structures being a way of packaging up multiple variables and calling them another thing. You can kind of think of them as proto-classes. So once we get into object-oriented land, the fundamental difference, right? You can package procedures with the data that they operate on, right? In C, you wrote functions, and in Python, you wrote functions. Functions are an abstraction of procedures, right? We can take some programming procedure, package it up as a function, use it multiple times, you know, reason about how it works. They're, you know, functions. Functions are good, functions are lovely. When you take functions and you're like, oh, I see that I happen to have a family of related functions that all operate on similar data, you take those functions, you collect them up with the data that they operate on, that becomes a class, right? That is a class, that is an object. You have a comment?
No.
No, okay. So, when we are operating with objects, it allows us to think about programs differently. We are no longer constrained to purely procedural thinking, right? We can now form what are closer to physical analogies with the things that we are creating in code, rather than a thing having only actions, it now has actions and properties. Things in real life have actions and properties. If I'm to take, for example, this remote control, it has buttons. Each button is a function, right? It also has properties, such as mass, location, color, the physical ones are obviously the easy ones, but you can imagine the thing as a piece of electronics will have some internal state as well. So you could model this thing in object-oriented programming in order to imagine it as behaving like an object. That's why it's called object-oriented, right? We are orienting the way that we are thinking about programming towards objects rather than pure procedures. It does require some adjustment. I imagine some of you in the crowd might be thinking, well, I only just got procedural thinking under control, and now you're asking me to think about things completely differently. And it's like, yes, that is the course, pass or fail. That is your main objective in this course, is to learn to think in terms of objects rather than in pure procedures. There will be some changes in the way that the terms are used. We no longer refer to functions as functions. We now refer to them as methods. There are basically, when it comes to object-oriented languages, different languages call different things at different times and depending on how they're used. So the particular terminology for each of these different things is dependent on which language you're learning. C++ has a different set of terms for things. Java has a different set of terms for things. Java was an extremely popular language, 20, 30 years ago, so you'll find Java's terminology pops up quite a lot in and around other languages as well. But anywho, come on in. Yeah. Any questions so far?
Like a deer in headlight.
Okay, good. We should talk about some of the more formal course stuff now that I've talked about other things.
I'll go.
The longer your password is, the more cryptographically secure it is, regardless of how many special characters you use. So, right, good. So, congratulations everybody on having found the class. We will be meeting Wednesdays, starting at 8 a.m. in this room, I-227. We will also be meeting Fridays from 1 to 4, so a 3-hour thing, in A021. You guys know where A-Wing is and where the basement of A-Wing is? You've had classes there before, I presume?
Yeah.
Good! So, the format of this class will run roughly as follows. The way I teach it, I cover a section out of the notes, then we have a period of time for in-class exercises where you try to actually program some of the absolutely lovely example problems which are published in Canvas, with the aid and assistance of somebody who knows what you're talking about, right? So 5 hours of that a week, basically. We will try to stay on schedule as best as we can. In addition to the in-class exercises, which are not graded and attendance is not taken, although class attendance is strongly encouraged, but there's no marks for it, there are a series of assignments. There will be, I believe, 10 assignments in total. Roughly speaking, 1 assignment a week. I'm sure everybody already knows this, as this course is, reasonably famous. So, nothing this week though. This week there's a practice assignment which you can use to test out the submission system, I suppose. But that's okay. So far as it goes. The assignments are worth 30% of your final grade. We will have 2 midterm tests and a final exam. The 2 midterm tests are worth 15% of your final mark each. The final exam is worth 40% of your final grade. That's the sort of grade scheme A. Grade scheme B takes the weight of the 2 midterms and places it on the final. I like to call this one the redemption arc. If you completely flub the 2 tests, and you somehow miraculously, and it does take something close to a miracle, pull your socks up, study so hard that you have Java coming out of your ears for 2 weeks, and then you write your final exam and you do reasonably on it. Basically, the maximum of these 2 grade schemes will be taken as your final grade for the class. I wouldn't get too excited about this, as I think the most I've ever seen that benefit a student is to the tune of about 4%. Normally, like, in test 1, you're being tested on easier material, right? In test 2, you're being tested on easier material. The material gets harder as the course goes on, so the exam is the hardest of all of these assessments. So, while it's not impossible to do better on the exam than on the midterms, if you didn't do well on the midterms, there is a decreasing likelihood that you will do well on the final, just because the structure of the course is strongly cumulative. I don't have to say the exam will be cumulative. I don't have to say that because the material itself is so structurally cumulative. There's no point in me saying it, right? It's like, week 3 and 4 when we start discussing objects and classes and methods. The entire rest of the course will use that material, objects, classes, and methods. This is a class on object-oriented programming, right? With 1 or 2 exceptions, that's true of every topic in the course. So missing a week, I won't say it's fatal, but you need to make up any time that you miss in this class, because it is very easy to be left behind, right? Because the course moves quickly, the material is not forgiving with respect to missing weeks or classes. Does that make sense? Good. Good. Relax. It's okay. We have a whole semester to learn this stuff, right? But constant vigilance. So, yep. So let's take a look at our syllabus. So this is a rough breakdown of the topics that we will be covering in the course and the weeks in which we will be covering them. Before we get there though, so aside from Python, what languages do people know? Anybody study Python, or anybody study Java before? couple of people at the back. Did it in high school probably?
University.
University? Yeah. Any C sharp? Yeah. C++? Yeah, okay. JavaScript. PHP? That one's less common, yeah. Oh, there we go.
Basic.
Basic? Ah. Like basic?
Yeah,
Where you had to put the line
beginners
numbers
all,
in yourself?
yeah,
That's,
with go-tos and all
Oh,
kinds of stuff,
man.
man.
go-tos are forbidden magic. We do not speak of them. The go-to is the elder magic of the programming world. What am I missing? Anybody got a language I didn't say? Any Rust programmers? Any Rust stations? No?
Ruby?
No.
Ruby? Okay, cool. Yeah.
Go.
Go? Sure, yeah. Anybody else? Swift? Objective-C? Anybody play around with an Arduino at any point? Good. So it seems that, like, you know, as is very typical for these sorts of classes, we kind of have a couple of clusters of people who've done a lot of languages, and then, you know, a few people who've done one or two, and then most of you have not done anything outside of Python. That is completely typical for a class in this semester. Don't worry if you've never done programming before you got here. The purpose of the program is to teach you how to do programming. So the class contains all of the information you need. All right? One thing that I often say to people, people sometimes get a little bit discouraged when they look around the room and they see, you know, oh man, like, am I the only person who's having trouble with this concept? Because, like, this guy is not even, like, he did it in like 5 seconds and now it's taken me like an hour, you know? That's unfortunately just kind of the way that programming goes. You should not compare yourself to the other students in the class to sort of get a handle on where your skills are. You should compare yourself to yourself from last week. That's how you should tell whether, like, it's much more important whether you're improving than to test yourself, try to test yourself against, you know, people in the class. Like, I guarantee you, there are at least a couple of people in the class who have been programming since middle school, right? And who are, in all likelihood, probably very good at it, right? Normally, in a class, there's at least one person who's a better programmer than I am, right? So, don't get discouraged by that. You're not, like, I do not take all of your test papers, give the best one the top grade and the worst one the middle grade, and then distribute you evenly between. That's not how I grade. You are not being compared to the top student in the class. What I'm concerned with is, do you know Java, right? Can you answer a Java question on a test? Do you know what it means to be object-oriented? Do you know the principles of encapsulation? Do you know the principles of inheritance? These are the things I'm concerned about, because these are the things that you must know. Unfortunately, for all of you, the level of difficulty of this course, Java, is, it's not that this is just the one hard course. Things do not get significantly easier after this course. This is programming, this course. Programming is difficult and unrewarding, although the compensation is not terrible, most of the time. Well, I shouldn't say that. There is a sort of, in programming, there is a kind of intrinsic, you know, solve a problem, get a dopamine hit. But, like, at a certain point, you know, with these Java assignments, I'm sure you'll find it unrewarding at points. There's this T-shirt that I like that says "Science is dull and unrewarding," which I think is correct. So this is science. This is computer science, right? You're learning how to program a computer. The better you do in this, like how well you do in this class and all other programming classes, in my view, is dependent on one thing, and that is how well you can train yourself to think like a computer. If you can think like a computer, you can program a computer. That is fundamentally the thing you're trying to achieve, right? Once you have trained yourself to think like a computer, I sometimes refer to this as the click. Programming will click for you, and you will find that in a relatively short period of time, almost instantly, you will be able to program at 4 to 5 times the speed that you were able to prior to the click. Like, it's actually that massive, the speed up, once you understand how the computer works, right? So, to that end, you may have gotten this impression from me already, but one of the things I like to do in my class is do nice little side tangents about like how memory systems work and how the computer actually works under the hood. I am trying to impart to you some of the secret knowledge that will hasten your understanding of how the computer system actually works. In my view, unless we are studying C specifically, it's kind of a lost cause, as C is the best language for learning how a computer works, but since I'm being paid to teach Java, I will teach Java. Begrudgingly, even though I'd rather be teaching C. So, any questions so far? Topics list done? So, this is the week 1. We are currently in week 1. Week 1, we will be discussing input, processing, and output, your famous IPO procedures. We'll go over variables, constants, primitive types, strings, expressions, casting, input, output, some documentation standard stuff, and also we're going to talk about the much benighted Java FX library, which we will be using for some assignments and as a kind of way to make it feel less like work. Even though it won't feel less like work, because it's a lost cause. Programming is work. But people seem to teachers seem to think that like coloring and pretty graphics are like motivational for students because I guess they think that you're all 5-year-olds. But that's it's not a bad skill, but it's also not. I don't like the Java stuff, but we'll do it anyway. Week 2, we talk about flow control, if statements, loops, nesting, switch cases, which probably you guys didn't do switch cases, but all of that stuff, which brings us up like probably to close to the end of Python, right? That will be over by the end of week 2. In week 2, we will have our first assignment. After that, we have roughly 1 assignment per week, unless there's a test. Or unless it's reading week. Make sense? So far, so good? Good. So, week 3, Introduction to Object-Oriented Programming. We're going to start small. We're going to discuss some useful abstractions that we use for designing object-oriented systems, particularly the Universal Modeling Language, UML. We will then talk about encapsulation, methods, fields, all of the building blocks that make a class or an object. We will also discuss the distinction between classes and objects. After that, we will discuss more object-oriented programming. Actually, you might as well just copy-paste that and put it in almost every subsequent week. Additional object-oriented topics, including constructors, what static members do, overloading, association. Basically, you can think of like the last topic before the test as being association. Then we have the test 1. We then move on to arrays. So in Python you guys did lists, right?
Mhm.
Arrays are like lists, but more persnickety. Also faster and more useful in certain contexts. You hopefully by the end of this class, you will understand when you use a list and when you use an array. Although that's also kind of like a data structures topic. Question?
Are arrays like tuples?
No and yes. Tuples are static once created. You can't modify an element of a tuple unless you destroy it and recreate it. Tuples are another data type in Python. Arrays can be modified, but their size is static.
Yeah.
So an array is an actual continuous chunk of memory where the indexing is given, but like basically you have the starting element of the array, right? That's at a particular memory address. Every element of the array is at an offset from that memory address. So it has to be one continuous chunk of memory to be an array. The difference between a list is each element of a list is actually contains the number, the item itself, plus a link to the next item. So you can just drop nodes in your memory freely all over the place. So lists are linked lists. Linked lists, traversing them takes time because you actually have to follow the data structure through. But with an array, you can instantly jump to any point in it because it's just a memory offset calculation, which you can perform in constant time. So that's the quick version. But thank you for the question. GUI layout, labels, buttons, text fields, and event handlers. You will be doing similar material in JavaScript at around the same time we are covering that in week 7. So there will be this weird week in the semester where you're doing like JavaScript in Java and Java in JavaScript, and then they'll go back and do their own thing again, and that's week 7. After that, we start getting into the hard object-oriented topics, after you've had a break after the test. Inheritance, which is notorious. Do not underestimate inheritance. Polymorphism, possibly worse than inheritance, depending on how well you got inheritance. Right? Does anybody in the class feel like you already know what inheritance is?
No.
Yes? A little bit? Well, we're gonna find out, aren't we? I like that. It's like nobody has any like wrong conceptions that they're bringing to the class with them. You're learning it all fresh. So, after that, test 2. So it's the rough structure is 4 weeks and a test, 4 weeks and a test, then the rest and an exam. After test 2, we will discuss exception handling, mouse events, do a little bit more graphics, GUI stuff. We will then, in week 12, talk about the list API. So we will actually talk about lists and how in Java you have this thing that is called an array list. And so, how does that exist when I just distinguished between arrays and lists and said they were stored in memory completely differently, We're gonna look at it. Turns out they implemented interface, but under the hood you can implement it any way you want. Because that's the type of abstraction you can do now that you're in object-oriented programming. Last week review, final exam in week 14, standard course layout, etc., etc. Any questions? Good. Pretty standard, right? So let's talk about fundamentals. So in my particular case, I've been teaching at this college since January of last year. This is my the third time round that I'm teaching Java specifically, although this is the fourth time that I'm teaching it, because this is the third semester in which I've had it, and the fourth, like in one semester I had two. Well, actually that's not true. This is the fifth, because I had two in the summer. Anyway, I've done this course a couple times now, right? Generally speaking, it has been my observed reality that the level of knowledge people have of programming coming out of fundamentals can be spotty, right? So I'd like to ask, please be honest, how did fundamentals go?
I crushed it.
Hmm?
I crushed
It
it.
was good.
Oh,
That was too
It
easy.
was pretty good.
good.
I wish it was harder.
Wish it was harder. Excellent. You're in the right place. So you feel like you learned the actual stuff then?
Mhm.
Yeah.
Yeah.
You had a good. Who was your prof?
Richard Ma.
Okay.
Hanin Sultana. She was pretty good.
Okay. Good. Sometimes you end up with a class that like 1/3 of the people had like a prof who didn't do a whole lot. You know.
That was
Yeah.
That you guys, yeah.
Ours was very
Okay.
good.
Okay. So like you know. Do you mind if I ask for a name?
Saeed.
Hmm?
Saeed.
Okay. Well, do not fear. Even if you did not know any Python whatsoever, Java is still a perfectly good language to be your first language, if you're considering this your first language, right? But the first few weeks are going to be rough, because you're going to have to get up to speed quickly, right? I will do my best to bring you guys up to speed, but you're going to need to do a little extra practice, shall we say, right? They show you guys coding bat in
Yes.
in Python.
Yeah.
You guys saw that it has a Java section too.
Yes.
Yes.
Good.
Working my way
That's an excellent resource outside of the in-class material, but there's also ample in-class material as well. We can, on a good week, we can probably get through at most 1/3 of the practice problems that are published on campus. So, there's lots to practice. Good. So, you are not expected to have any prior knowledge of Java. That line is in the course description probably because frequent feedback about this course and many other programming courses is, it really seems like this course expected me to have prior knowledge of Java. Prior knowledge is always helpful, but not specifically required. The course has been designed as well as a programming course can be to not require any knowledge of Java going into this Java course, otherwise what would be the point? So, course description. Design object-oriented applications in Java that make effective use of encapsulation, inheritance, polymorphism, interfaces, abstract classes, associations, and arrays of objects. Create desktop applications that display graphics and use graphical user interface to communicate with the user. Work with arrays and array lists to store and manipulate data. This is just a recapitulation of all of the topics. The important thing to know about that, we are not doing any web programming in this class. We are just making executables, right? Just plain old desktop executables, write the code, compile it on your machine, run the code, see if it works type things, right? Even though the native application, as they are now called, is an increasingly rare species in today's software landscape, it is still an excellent place to get some training. So that is what we're doing. You'll have plenty of time to talk about web technologies in your classes on such. So, the environment that we will be using, the IDE for Java that is installed on each of these computers already, is IntelliJ IDEA Community Edition. There are instructions on downloading and installing it for your local computer, which I will be going over today. So I'm very glad that everybody came, because this is actually a fairly important class. In addition, the specific version of Java that we will be using is the Liberica JDK, or Java Development Kit. This is different from the Oracle/Sun Microsystems version that likely is already installed on your system if you already have Java installed. Which, how many Minecraft players do I have?
What is that?
These people all have Java. So, yes. So if you'd like to install locally on your own machine, there are instructions to do so. If you would prefer to do your in-class exercises on these lab computers, it should, in theory, be installed and working right now, and you can just download it from Apps Anywhere, and that should work. Make sense? It doesn't get any more complicated than that. We're not even particularly concerned with the creation of standalone executables in this class, so long as the thing is running inside of the console in the IDE. That is as far as we're interested in taking it for this one, with the exception of like pop-up windows for the graphics stuff, because obviously that's a bit different from a console app. If you're familiar with the term console app, that is what we're making here. Basically, these are programs designed for a text interface. Make sense? So far so good? That's probably pretty similar to what you did in Python, right?
Yeah.
Good. Any questions? Yo.
Is 17 okay? Because I don't see 15 readily available on the website.
Oh, is that the case? Well,
I mean, it's probably there if I look for it, but.
Ordinarily, yes. So, that's Liberica, right? Yeah. Yeah, go for 17, I'd say. But I'm kind of jumping ahead of my spiel, so I'm going to give my spiel. So, get out of here, Chrome. Nobody likes you, Brave is better. So,
Excuse me.
oh, yes, question?
You mentioned about console, so could you explain like what is console and RV?
Oh, yeah, sure. So console is just the general term that you give for a command line interface that's been embedded inside of an IDE. IDE, Integrated Development Environment. So IntelliJ IDEA is an IDE, Integrated Development Environment. What that means is the text editor contains a compiler. That's it, really. It contains a compiler and a way of running the code you're compiling. That's an integrated development environment. That's what integrated means. This is slightly different from, strange people such as myself who tend to have their text editor as, just a running program, and then I compile in my own bash shell because, as you're going to find out very quickly, you have the fortune or misfortune of a professor who is in the cult of Penguin. So, basically, if it's not Linux, I don't care. Windows is only permitted on sufferance. So, like when I do things in Linux, because this is the way you do things in Linux, like you're just kind of compiling things in Bash and running them from like an actual Bash shell. Basically what the idea of a console is you take that Bash shell and you pop it into the editor itself, and that's a console. So when we say console app, all we mean is it's designed to be run on a command line interface, basically. Again, except for some of the GUI stuff that we're going to do later in the course, but you know, that's the exception here, not the rule, right? So, yes, each assignment covers the material covered in the last week in class. So, the assignment in week 4 covers the class material in week 3. Again, don't miss class. Don't do it. Don't do it. Don't miss class. Don't do it. I know it's an early class, but don't do it. Tests will be closed book, pencil, and paper tests.
That sucks.
So, this is sometimes a controversial decision, but when it comes to the maintenance of academic integrity, there is a lot to be said for good old pencil and paper. We will write the tests here in the room during our regular class time. Don't worry too much about things like, oh, what if I make small syntax errors? He's going to take a bunch of marks off and I'm going to fail a test because I forgot semicolons. I do not fail people on tests because they forget semicolons. I fail people on tests because they fundamentally don't understand Java programming. That's why you fail a test. Basically, the Java tests tend to be split into 2 rough sections. One section you're required to produce in like almost individual lines of code, or in a lot of cases, individual lines of code. Things like declare an object for me, right? Declare a variable for me of a particular type. With those, we have a higher expectation that you'll get the syntax correct, right? The second half of the questions are longer questions. Write an algorithm. With those types of questions, we are not so much concerned that you get the curly braces right and you get the semicolons right. We are concerned that algorithmically you're thinking the correct way, right? So on that half of the test, and between you, me, and the fence post, that always tends to have more marks associated with it, the algorithmic section, we are not looking at syntax, we are looking at semantics. And I hope if you derive one thing from being stuck in a room with me for 50 hours this semester, I hope it is the difference between syntax and semantics. So, because that's actually like, that's like topics that around and about which I did my PhD on, so. I wrote a compiler. That's what I did for my PhD. It took me way too long, and I'm glad I'm done.
In what language?
Oh my goodness.
Tell me it was assembly.
It was worse than assembly. Have you ever heard of an
Malbouge?
FPGA? Field Programmable Gate Arrays. Hardware description languages. See, in assembly language, you get to use an instruction set.
Uh-huh.
In a hardware description language, you are programming logic gates.
Huh, that's interesting.
Yeah, so basically the thrust of the compiler was to take hardware descriptions written in one very specific hardware description language, BlueSpec System Verilog, if anybody wants to look it up, and then cross-compile them to another extremely obscure language called Prototype Verification System, which is a logic language, like in the logic language paradigm, so that I could run formal mathematical proofs of correctness over hardware descriptions, as abstracted by my methods. And it kind of worked for some examples. And that was good enough for
To get your PhD,
Yep.
perfect.
And it took me 10 years, which is longer than average. But I also was working on it as a master's student and transferred to the PhD program, so I guess technically I was doing it for 8 years as a PhD student, but too long. I spent too long, I should have been out making money. Anyway.
Yeah.
And then I came to work here, so I'm still not making any money. I just hate money. That's just that's just me. No, what it is I prefer a profession where I get to be a professional know-it-all. Anyway, so if anybody has any accommodations of any way, shape, form, or size, or description, please get your letters in. I don't think I've gotten any letters yet this semester, so the sooner you get them in, the sooner I can apply them. So we should discuss the policy with respect to assignment submission. My understanding is that you may have seen a policy like this in Python, a late day policy.
No,
HTML.
it was HTML, but Python had functionality.
Oh, okay. So you know it from HTML though?
Yeah.
Okay, so,
The Python one was like, day late was like minus 25%, 2 days
Oh.
was like minus 50%, and 3 days was like,
75%, then,
old school, I like it.
oh, okay.
So let me recap the policy then, because it's been a long time since last semester. In this course, you are afforded a bank of 10 late days.
Oh my god.
10 late days and 10 assignments. So, on average, you get 1 late day per assignment.
I'm gonna save them up.
So, in this particular class, just let me read it. Yeah, sometimes I teach a Steve Adams course and he locks it in that you can't use more than 3 on any one assignment. But remembering this one's not that. So you are free to use as many late days on whichever assignment you wish. But once you're out of late days, that's it. And no assignment submissions will be accepted if you are out of late days, barring exceptional circumstances. So, if, for example, at the beginning of the semester, you fall down a flight of stairs and break your leg and have to use up all of your late days, actually, you wouldn't actually have to use late days in a situation like that. I would afford you some kindness if you
Fall in
actually
a
have a
hole
serious
someplace.
injury. Let's say you were lazy at the beginning of the semester, you used all of your late days, and then at the end of the semester, you did fall down a flight of stairs and break your leg. You're not completely just screwed because you fell down a flight of stairs. I am not an ogre. I will make reasonable accommodation where reasonable accommodation is called for, but don't come to me when you've used up all of your late days and say, oh, can I submit 3 assignments in the last week because I didn't do them? And it's like, no, you can't. No! Try again next semester. Yeah, so is that clear how the policy works then? As I'm marking your assignments, one of your grade items will be the number of late days you have remaining. Although it appears in the grade book, it's not worth marks. You don't get more marks in the course because you kept all your late days. They're free to be used. That kind of would defeat the point, right? So yeah, but that's where that information is reported to you, is in the grade book on Canvas. Make sense?
Mm-hmm.
So far so good? Excellent. So, if you know you're going to miss a test, it is possible for me to do something for you. If you tell me you have missed a test after the test has occurred, the possibility of me doing something for you is significantly less. Significantly less. I can make some reasonable accommodations where possible, but you're gonna have to have a reason, right? And I need to know ahead of time. Reasonable?
Mm-hmm,
I hope people think that's reasonable.
generally.
Good. Working together and helping each other, otherwise known as the section on academic integrity. So, be warned. I check for plagiarism. I convict people for plagiarism. I have been known to convict quite a few people for plagiarism in the past. I used to teach at McMaster University, and when I taught, there was this one interesting year. I didn't have much plagiarism like the year the pandemic started, but the second year of the pandemic, it was rife with plagiarism. And I am very proud to say that I was able to process through and convict 1/3 of 400 students over 2 semesters of plagiarism, primarily from primarily self-plagiarism off of other students in the class, but the second big one was Chegg for that particular one. So if any of you use Chegg, please stop. I am begging you. It is a plagiarism website. There is no, in my opinion, there is no legitimate use of Chegg as a website. It is just an aid to plagiarism, nothing more, nothing less. And anybody who thinks otherwise is wrong. So what constitutes plagiarism? Most of the time, although I do convict quite a few people of plagiarism, believe it or not, I don't normally have to scrape the bottom of the barrel to find people. Alright? It's really basic stuff. If you copy and paste other people's code, that's plagiarism. Do not share your code with people. Do not post your code to your friggin', Discord servers. I know Discord servers. I know that's where all the stuff goes down. If you're posting your code,
It's not MySpace anymore?
particularly public, nobody's using MySpace anymore. If you're posting your code in a public place where, people outside your friends, people outside this section can find your code, someone is going to steal it. Someone is going to submit it as their own. And someone is going to get you a plagiarism charge, right? In fact, you are completely liable under the plagiarism policy as you failed to adequately guard your work against plagiarism, right? So please, 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 consider your work your own, and it's not your responsibility to get your dumb friend through college, all right? I know that it's there are social consequences to saying no to someone who's asking for your code, but please do not give it to them. Because, listen, they are not just gonna look at it and be like, oh yes, that's the general principle which applies in this situation. I'm going to take that general principle and write my own code entirely on my own. That's not what's going to happen. They're going to take your code, they're going to change the variable names and submit it as their own.
If they
And
even do
it's-
that.
They often even leave in the comments.
Mm-hmm.
Question.
So, is it plagiarism to copy a bubble sort algorithm from online that's just publicly available? Because bubble sort is one of those things that just is known,
Mm-hmm.
and it's not considered public knowledge at that point.
So, the algorithm itself is different from the implementation. One of the ways in which I often justify a plagiarism complaint against a student one of the things that students often come to me with during plagiarism review cases is, oh, well, you know, there's only one way to do this, right? As it turns out, there are, like, anytime you put, it's very similar to writing an essay, right? Two essays on the exact same topic, using the exact same supporting reference material, etc., will both look extremely different, right? Because each person chooses slightly different ways of wording things, slightly different, you know, to compose a piece of code is to make, 10,000 small decisions. Each of those small decisions apart, sure, two people might make the same decision. But if two people make the same 10,000 decisions, that's plagiarism, right? Now, in the case of your particular question, which is, you know, do I have to reinvent bubble sort? Not generally, no, but bubble sort is a pretty short algorithm, right? Basically, the degree to which what I just said applies is dependent on the length of the algorithm, right? The more code there is on paper,
No decisions.
the more little tiny choices went into that code, the more unique it will be to you. I could not in good conscience convict someone on the basis of four lines of code, right? Unless they copied comments. If they copied comments, you're done. Just like, you know, do not pass go, do not collect $200, you have a plagiarism charge if you copy comments. Because like, that is optional material to the, you know, like, not only is it composed by, you know, you, like rephrased comments also count. It's like English text, which is pretty easy to detect plagiarism in. Just don't do it.
So what I'm getting is that as long as you can't prove it, you don't mind?
Well,
Not exactly what I got from that,
well, see, you lose 20% of your grade if you don't comment your code. So, yeah, that's another thing.
To make your own comments?
Write your own comments and write your own code. That's what you need to do. Yeah,
It's insultingly
commenting.
lazy.
Let me put it to you this way. The majority of my cases are not on the basis of people were stupid enough to even copy the comments over. That's like the creme de la creme of the easy plagiarism case for me. That's not the only way I catch people by a long shot. In particular, this semester a few changes have been made so that Turnitin can also be leveraged against you. So that is going to allow us to check not only people, I'm not only looking at yours, like everybody in the room, but if you're, you know, if you were clever and got a group together of like one person from every section and all cheated together, imagining the profs aren't looking at each other, they aren't sharing the solutions, Turnitin is gonna get you. So just don't cheat. That's like the easy thing is just don't cheat, right? But
Reasonable.
we kind of enter into a kind of a more general discussion of to what degree is the, you know, what is the level of permissible sharing of code, right? Because there is a kind of a strong industry argument in favor of copying code, right? Not of copyrighted code, but of non-copyrighted code, right? In fact, this is the heart and soul of the open source movement. Here is my code, please copy it, right?
Has to be attributed.
So, sorry?
Well, as long as you include proper attribution.
Certainly, yeah, exactly. Like, the various licenses that open source software is released under are not simply, here, take this and pretend you wrote it. It's here, take this, please, you know, spare a moment to attribute the code that you used from me to me in your code, etc. But it's like there is a strong element of like the collaborative creation of software, right? This is fun and good. This is actually a moral good. Collaboration is a moral good. That's why this section says working together and helping each other. But there is a difference between collaboration and theft. Plagiarism is theft, right? So, yeah. Am I making myself sufficiently clear?
Mhm.
Hopefully. And hands up, anybody who's going to plagiarize this semester? Okay, good. No hands. I'm happy. We shall see, though. You're intending on plagiarizing, or do you have a question?
I have a question.
Okay.
So you mentioned there are multiple ways to write a program or something.
Yes.
Is there a way to learn like what are the different ways or something, or so
Well,
if you find any code on the line, and if you want to know what are the other ways, or
so
What it does.
code is kind of such that if you look on the internet for a specific problem, like if the problem is specific enough, you'll probably find a lot of different solutions to any specific problem. They're all going to look differently. See, when it comes, like, the different ways people have of approaching a problem, it's not that, you know, it's not that there are certain fixed ways of approaching it. Programming is fundamentally a creative endeavor. Everybody's brain works slightly differently, so everyone codes slightly differently. It's like, again, it's like writing an essay, you know? It's not that there are 3 essays, and that you pick one of those 3 and write it, right? You write an essay on a topic, to the best of your ability, you construct sentences, you construct the language to make an argument. In the case of programming, you construct the language to make an algorithm, right? You may all be shooting for the same algorithm, but so long as you're not doing a trivially sized textbook example like bubble sort, your individual, the way that your brain works will dictate how your code works, right? And to ask, how do I learn the alternatives is like, it's like asking, how do I learn how other people's brains work? And it's like, it's a very interesting exercise. Poking through somebody's code to see how they think about it, that's actually like, that's a strongly beneficial activity, if you have time for it this semester, right? But right now, all of you are at the very beginning of your journey through the land of programming. It is likely that you don't, and I'm not trying to be mean or anything, but you're not sufficiently fluent yet in programming for that to be necessarily a useful activity at this level. You need to drill the basics until you have those completely down pat. You need to have your own style, and then you can start learning from other people's styles and taking the best of their styles. I had a martial arts instructor once who told me something which I think is applicable here. He said that there are 10,000 beginners but only 3 masters. And that's kind of true, because when you're first starting programming, or anything that really like requires proper skill, because programming requires proper skill, right? When you start off in one of these things, you're coming to it with all of your own ideas about how things work, your own misconceptions, preconceptions. Your brain works a particular way. So all beginners, to some extent, are the same when they first start off, because they know nothing. Quickly, that expands out into your own programming style. Once you become fluent in programming, you find your own style, it works, so you hone your own style, right? Over time, you find the efficiencies, right? So as you are, a practitioner of programming, you will gradually find, oh, you know, that technically works, but if I did it slightly differently this way, it's a little bit more efficient. It's a little less hard on the CPU. This saves a bit of memory, right? All of these tiny decisions will eventually sort of prune off the extra work that you're doing that you don't need to do. And eventually, you'll converge on the sort of, you know, the state of being one of the three masters, right? You'll sort of converge on being like the apex programmer by removing from yourself all of these behaviors that are not necessarily useful or contribute to the correct solution or work as well as they could. But like, we're talking about a process of decades, right? And, you know, most of you are relatively young people. You have decades to sort out your programming styles in, and just, you know, embrace the journey, I guess is what I'm saying. I don't know how this class got to this point, but embrace the journey, okay? And trust the process. Trust the process and embrace the journey. Programming can be a beautiful thing. Like, just the magnificent, beautiful music of the universe itself, mathematics. But you have to open yourself to it. And you have to be willing to empty yourself of yourself and become an avatar of pure mathematics. That is what your goal is over the course of your life as a programmer. And I hope that some of you at least are able to achieve that. So, anyway,
I just want my cash.
what were we even talking about? Plagiarism?
Yeah.
Don't
Generally.
plagiarize. Moving on.
TLDR.
Yeah, TLDR, don't plagiarize. Good, wonderful. So, shall we talk about how to actually get the frigging Java software then?
Sure.
Or what it even constitutes? Let's talk about Java. The Java environment and all of the Java stuff. So, all right. We're going to talk about some like compiler concepts now. Who can tell me what a compiler is? I just told you that I wrote one for a PhD. Presumably I wrote a thing. What is the thing that I wrote? Yes?
Something that translates human language or code into machine language.
Yes. Very good. That's a very precise definition. A compiler is a program which takes something encoded in a programming language and converts it by mysterious processes that you don't need to know about, but if you want to know, you can ask me after class. Converts it via mysterious process into machine code, machine executable code. This is the typical process for many languages, right? So I'll take, as an example, my favorite language, C, right? So if this, I need a new marker. My goodness. Let me try blue. So imagine this as your computer or your operating system, right? Things running on your operating system will be placed on the line, right? Let's imagine that we have a C source code file, right? What we do, we have our compiler, which is a program running on top of the operating system. In this case, we will use the only correct C compiler, which is GCC, the GNU compiler collection. The C file goes in, gets turned by mysterious processes into an executable file. I am giving it a .exe extension purely for the benefit of you Windows people. In true Linux, what makes a file executable is the fact that the file has executable permissions set. There is not actually like an executable file extension. It's a more general concept than that in Linux. You will find, I hope, all of my digressions on Linux very useful when you get to PHP programming. Because guess where PHP is running?
Linux?
On a server. Guess what kind of server?
Like 99% of all
Linux server?
servers. Linux.
Yep, an Apache server, which is a Linux distribution. So, Linux is cool, and everybody should get rid of their Windows and get Linux. So anyway, the compiler compiles the source code into an executable, but the executable itself is just a file, right? It is a sequence of instructions, but now it's machine code instructions. That means the instructions here are not really interpretable easily by humans. There was a day before compilers. The graybeards programmed in the assembly language of the CPU itself. They did so on punch cards. But, you know, we have more modern methods. In order for the program to actually be run, it must be executed on the operating system as a program the same way that the compiler was run. So, it gets run on the operating system. Does this make sense? Yes.
When you say the operating system, do you mean like the kernel or directly onto the hardware?
What I normally mean is a shell.
Okay.
So you have the kernel, right? The kernel is composed of the deep processes of the operating system. Things like communicating with your keyboard, communicating with your mouse, communicating with your memory system, moving stuff around. The C standard library is considered a part of the kernel, stuff like that. On top of the kernel, you have a shell. And this is not just Linux, this is true everywhere. The shell is what we think of when we say operating system. Your Windows desktop is a shell, right? Your bash shell is a shell. It's the born again shell, bash. The shell is the thing in which you launch user programs. These guys are user programs because the user asked for them to be run, right? So, in Linux, it's actually called user mode. They're running user mode. So, you know, if I'm calling this, you know, q.c, q.exe, right? In the shell, you ask to run q.exe. It runs on top of the shell, which is running on top of the kernel, which itself is technically running on top of the hardware, right? Does that make sense?
Yeah.
Cool. So, yeah, these are programs in user mode being executed in the shell. Question?
So if user programs run on the shell, is there anything that runs on the kernel? Would that be like a computer? Like an example of that?
Well, the shell runs on the kernel.
Oh, I guess.
And you can have a lot of shells, actually. You typically, like, Windows tends to think of itself as being one shell with a kernel inside, but, like, in a Linux type environment or a server environment, you think of, like, each like, shell that's, like, you can have, imagine a server, right? Imagine a server with 100 people logged in who all have a command line prompt open. That's 100 shells, one kernel, right? So, and each one of those will be running their own user program. So, does that answer your question?
Yeah, kind of like if you would run a virtual machine on your computer as well, that would be two separate shells, is running off the same kernel, or are you creating a whole new?
I love this class. You're a good class. So if you have a VM running, right? The VM is a user program on this shell, right? So that's your VM. The VM is emulating another kernel, kernel 2, right? Kernel 2 has shell 2, And then shell 2 has user programs running on it.
Okay.
Right? The advantage of a virtual machine is that basically from this layer on, it's hardware independent. As long as you have the guts in the computer to be able to run whatever operating system it is that you've spec'd out in your VM, like you can run a full-bodied Linux distribution from inside Windows if it's in a VM, and it will behave precisely the same way that Linux does because it's being emulated quite well by a virtual machine. Virtual machines are something we don't really talk about yet. I think you'll get to them eventually. Question?
Okay, so these are basically nested kernels, which means that you can have virtual machines running on virtual machines.
Certainly. At a certain point, though, you're going to hit your hardware limitations pretty quickly,
Okay.
right? Because the kernel here, right, must go through the operating system to get to these kernel operations. That's less efficient than just being this kernel, right? There's like, that's why a VM will never run as fast as the thing it's running on, right? That's why there will always be a purpose to having a natively installed Linux distribution, right? You only have so much RAM, right? When you run a virtual machine, you're taking like half your RAM and you're giving it to the virtual machine, and it's no longer available for the base operating system, and you can only divide your RAM so many times, right? Before you no longer have enough RAM to support an operating system, unless it's like something like Xubuntu, which is, or another extremely, or Bodhi or something, extremely lightweight Linux distributions that can run on poor laptops from 20 years ago. But yeah, eventually you just run out of hardware. But yeah, so we're kind of getting a little bit off topic though. Are there any other questions? This is important to understand about how your computer works though. Yeah, okay. So that's a compiler, right? Does anybody know what an interpreter is? Somebody other than you? Yes? No?
Mine's empty.
Okay, go for it.
So, an interpreter is like a compiler, but instead of having a file, compiling it into another file, it just interprets it line by line.
Mm-hmm.
And-
Yes, yep. Not a bad description. So, interpreter. And do you know any interpreted languages? Python, that's correct. So Python is an interpreted language. So if we have q.py, right? The way that it works, the Python script is compiled at the same time that it's executed. Or it's compiled one line at a time, and then you execute as you're compiling. That's one way of thinking about it. So when, and you know, most of these languages, interpreted languages, have some capability of producing a standalone, but don't be fooled. All that a standalone is, in a lot of cases, is the interpreter, which has been packaged up with source code, right? They aren't actually compiling down to Python, down to machine code most of the time. They're just packaging it up with the interpreter, right? So it's sneaky. Interpreted languages are sneaky. So with Python, and everybody should know this because everybody did a course on Python, when you run a Python program, do you get an executable file?
No.
You do not. You just feed it into a program and it executes. So, you run Python 3, right? your q.py gets slotted into it, and then you get your output. Oh, I should say up here, this is where the output gets put, right? Make sense? So the Python script itself, in a sense, never touches the shell directly, right? It is being interpreted by the Python program for the operating system rather than running directly on the operating system. Does that make sense?
Sorry, say that one more time?
Sure. The Python source code is being interpreted for the operating system, not being run directly on the operating system. Q.py is never being collected up, parsed and processed, and machine code produced. Each line in a Python file gets read in one at a time, turned into machine code in some manner, one line at a time, and executed without that ever being stored to a file. Does that make sense?
It's like the interpreter is a special shell for the Python file.
Precisely so. In fact, in many cases, interpreted languages will have a command line interface version which they call the Python shell or the JavaScript shell. So yes, this acts like its own shell, but it's a shell that only accepts Python. So yes, whereas of course the operating system will accept a lot of things. Yeah. Well, it won't accept tuna fish sandwiches, but you know. So compiled languages tend to be faster once compiled, right? We're talking about languages like C and C++. Interpreted languages tend to be slower, but they do dynamic checking, dynamic runtime checking. In this case, all of the guts of the compiler, that's all over and done with completely by the time the program is actually run. So any correctness checking you're doing is done up front. In the case of Python and other interpreted languages, a lot of the correctness checking that's done is being done at the time. This is how it gets away with having a dynamic type system. Does that make sense? So when you are looking at languages with dynamic type systems, you can put money on it that there's an interpreter involved in there somewhere. So, you guys are taking JavaScript. How many, is anybody not taking JavaScript this semester? Is it because you already have JavaScript, or?
I'm actually in networking.
Oh, well, welcome. I hope you're enjoying the class so far. So, with JavaScript is an interpreted language, but that interpreter, there's like one more layer right here, which is your browser, right, for JavaScript. So, all right, we should have a reasonable understanding of the difference between compiled and interpreted languages. So the question becomes, what is Java? Anybody want to hazard a guess?
I want to say compiler just because I think Java is closer to C than Python.
Mm-hmm.
So that makes me think compiler.
That's not a bad heuristic. Java is a lot more like C than it is like Python. Anybody else have any guesses? Compiled? Yeah?
Compiling?
Compiled?
It's a little bit of
Because
both,
the
I think.
syntax, it may be because of the syntax.
Don't you need the Java runtime environment?
But don't you need the Java runtime environment, he says. Yes. So, yeah. the truth is that Java is both. It is both a compiled and interpreted language. So, this is how a Java program gets run. Is this high enough everybody can see it? So, you start off with your .java source code file, right? The first step, and incidentally, like the ID is gonna IntelliJ is gonna hide like some of these details for you, but to have studied Java, you need to know this. That's why I'm telling you. So, the first step is to run this file through the Java compiler, which is called JAVAC. Java compiler, JAVAC. In it goes. Your output is another file, but it is not machine code. It is a .class file. Q.class. Now, in order to run that bad boy, you now require Java, the program called Java, which is the Java interpreter. And that gets run in the same way as up here. So, Java occupies an interesting position in the history of programming languages. It was one of the first languages to have interpreted code rather than directly compiled code. So, when it was initially developed, you're kind of in a culture that expects a compiler, right? As people saw how useful the interpreter can be, later languages came along which dispensed with the initial compilation stage. JavaScript, which is based on Java, Python, which is more C-based but takes the interpretation idea and runs with it. So this here is known as the JVM, or Java Virtual Machine, which is likely a term that you've heard before, right? This was a quiet revolution in the way that programming is done. So, prior to the existence of the Java Virtual Machine, you had a basic problem where code written on one machine was not necessarily executable on a different machine. Different computers had different architectures. Different CPUs had different instruction sets. This was a problem that was to some degree solved by C previously, but not sufficiently well, right? So the problem that C solved is not having to write different source code for different computers. If you can imagine it, back in the 60s, if you had two different computers, you had to write two different programs for them, right? Because they had different instruction sets. The kids at Bell Labs, Dennis Ritchie et al., designed so you see how it's like GNU compiler collection, right? It's a collection of the compilers. They didn't write a C compiler. They wrote a C compiler for every known architecture, right? So that meant a person could write a C program, pop it onto a floppy disk, take it to another computer, put it in, compile it, and the program would run on that computer. This was revolutionary at the time. It allowed the development of the modern operating system, and that's why C is the occupies the position of privilege in the history of programming languages that it does. That's why C is important. That's the problem C solved. Question?
How do you spell the GNU compiler collection? So
Oh, it's
G.
GNU, like the
Okay.
animal.
Okay, got it.
Yeah.
Thank you.
What Java did with the virtual machine is it took it one step further than that. First, it separated out compilation from execution, right? It did that for particular reasons. Whether or not that was a good idea, remains to be seen historically. But what Java allowed is the embedding of the Java interpreter in things other than the bare operating system, right? So the reason that browsers support JavaScript and a JavaScript interpreter is that they originally supported Java, and you could run the Java virtual machine from inside of a browser, right? Now, over time, that language developed into its own language, which became JavaScript. Incidentally, Java is to JavaScript as car is to carpet. You will not find knowledge of Java and JavaScript to overlap as well as you think they will. Unfortunately, they're very different languages in the way that they operate. So, unfortunately for all of you, you are, if you went into this semester being like, oh, I've got one language in 2 classes. It's like, nope, not even remotely. They're very different languages. But that's the reason. That's the key innovation. That's why Java became extremely popular. So, in the modern sense, everything on this side of the line, we consider that the JRE, or the Java Runtime Environment. So when you download Java, you have the option of downloading one of 2 things, the Java SDK and the Java JRE. The Java Runtime Environment contains the Java interpreter, but it does not contain the compiler. It is not possible to compile Java programs using the runtime environment. That's not what it's for. It's for the end user, right? The standard development kit is the whole thing. The standard development kit includes the runtime environment, and it includes the compiler, so that you yourself, even you, can write Java programs, compile them, and execute them. Does this make sense? Good. Any questions? Yes.
If there's any other ways to convert code to machine language for the computer to read, or is it just the 2?
Like other than compiled and interpreted?
Yeah.
Probably, but they haven't been invented yet.
Fair enough.
Yeah.
Yeah.
That's 1%.
I'm not ruling it out. One of the things they do as a PhD student is they thump out of you the desire to make any claims about things that you don't have proof for. So I absolutely can't rule out that there's nothing about these 2 schemes which makes them exclusive of other schemes of doing this, right? You could argue that running things inside of a virtual machine mixes this up sufficiently that neither one of these is really, you know what I'm saying?
Yeah, I know, yeah.
But I'm gonna leave room for future innovators of programming languages to find other ways of doing things. This is the state of things in 2024 though. Yes?
Just for some clarification, the JDK that we're downloading, is that the same as the SDK? just
Yeah, they're
Java?
calling it Java Development
Java
Kit
development
and standard
standard,
standard.
yeah.
Yeah, so Java, like. Okay, so maybe now I should explain why there's anything other than the Sun Microsystems version, right? So, how am I doing for time? Getting close, okay. So this is how languages, used to work, alright? Not as much anymore, but this is why there's more than one C compiler, why there's more than one C++ compiler. This is the reason, alright? The way things used to work, a company that designed a language would design a specification for that language. That would be that company's intellectual property. They would license that to other companies who wrote the compilers. So, AT&T, who owned the C specification, licensed that specification to other companies like IBM, so they write Clang, right? And they themselves have their own C compiler, that's their in-house version, right? That's why you have all of these different versions. The specification is not exhaustive. There are small design decisions that can be different between these different compilers, particularly once you get under the hood, like the optimizations that are optional and that sort of thing. So, Java is still in that category of language. The Java specification must be adhered to, so Java must work the way that it's been laid out by Sun. Sun has their own in-house version. But other companies can license that specification, make their own compiler. Liberica, like in recent years, this structure has been kind of fraying and blowing apart. Open source has been doing a lot to break apart proprietary software practice like this. So what Liberica is it's an open source implementation of the Java specification. The reason that we're using it over Sun's version is that it includes JavaFX and Sun's does not. So it's got libraries that we're going to use, and that's the reason we're using that one. But I agree that it's a complete pain in the arse because going with the default is always going to be easier, and we're going to have to configure IntelliJ to use the right SDK. That's a problem we'll figure out. We'll get there, don't worry. Man, I've got 5 minutes left in class. Do you guys want to see Hello World in Java?
Sure.
Yeah.
Okay, let's do it.
Public stuff.
Just give you a brief look at,
Uh-oh.
where's the bloody remote? Is it on the desk?
It's not in your back pocket?
I'm even blind with my glasses. So, this will be the applicable process for all of you who are doing things on lab computers. If you're doing this on your own computer, you'll need to install the software, obviously. So, you go to Apps Anywhere. You can just cancel out of this one.
You have to figure that out first semester, but not last semester.
You gotta log in. I'm obviously staff, but you're not.
Isn't that an interesting number? 23002.
I know, right? I love that number. If you exclude the first 3 digits as a
Yep,
palindrome,
it is.
yeah.
What's that?
So, good morning. What would you like to launch? IntelliJ. IntelliJ Community 2022.1 launch.
But that's just the school one, right?
Here we go. This is the IntelliJ splash page. From it, you create projects. You have to create a project to run Java code. Let me get off there. Okay, that's as good as I can do. New project. Sure, untitled. Language is Java. Build system is IntelliJ. JDK is Valsoft Blank-Birica. Right? On your own machine, if you had a pre-installed Java version, it might give you something other than Liberica here. You need to select Liberica for the JavaFX stuff to work. Create. There we go. So, in your source folder, right-click, New Java Class. In Java, classes and files are the same thing. You put one class in one file. That's how Java expects you to do it. Not a technical hard requirement, but that's good practice. Let's call this example. There we go. Public class example.
Could you show again how to open that?
Yep. Right click, new, Java class,
Oh,
give it a name. If you open the folder, you'll see we have example right there. And you know, if you look in the folder if you look in the directory, then you'll see one .java file called example in there. Currently containing public class example. So, who can tell me how you print something in Python?
Print.
Print. Yes. Well, in Java, first, it must be inside of a class because everything must be inside of a class. Number two, it must be inside of a main function because the only thing that gets executed is the main function. So, public static void main string array args, I believe.
That's the incantation right there.
There we go. Public static void main. I believe the shortcut is mains tab. Yes, did I get it right? Aha, I did. So, you can, IntelliJ has a few shortcuts. Main tab gets you that. So, you don't just say print, you say system.out.print line hello world.
Can you maybe zoom that a little bit?
Oh, yeah, sorry. There, is that better?
Yeah, it's better.
Cool. There we go. Save that up. Then run example.main. There we go. Pops up our console. Hello world. Does anybody need me to post the code? If you select add default code, this is what it adds. So. Public, static, void are all terms that we will have classes on. Main, we'll discuss next class. System.out, we'll talk a little bit about that. That's like, for those of you in the know, that's basically std out. That's your standard output stream. That's accessing your standard output stream. And, you know, hello world is just a string. But a little bit more verbose than Python, eh?
A little bit.
Just a tad? But everything makes sense and it's actually there instead of just being implicit. But anyway, I think that we've probably done enough damage for one day. Any questions? Okie dokie. See you on Friday.